Welcome to This Explainer, where we're going to break down India's incredibly ambitious next step to the moon. You know, we all watched ISRO make history with Chandrayaan 3, right? But their next mission, Chandrayaan 4, is just in a completely different league of complexity. Okay, let's talk about the elephant in the room, 9,200 kilograms. That is the massive weight of the Chandrayaan 4 spacecraft, and it is literally the root of the biggest engineering problem ISRO is facing today. Because, think about it, to pull off a mission that lands on the moon, digs up rocks, and then flies them all the way back to Earth, you need a staggering amount of fuel, hardware, and highly specialized equipment. And all that weight creates a massive logistical hurdle. To put that into perspective, Chandrayaan 3 weighed a very respectable 3,900 kilograms. But because Chandrayaan 4 needs to actually make the return trip, its 9,200 kilogram bulk is just way too heavy for a single LVM-3 rocket to lift into orbit. ISRO's current heavy lifter can really only push about 4,500 kilograms into a geo-transfer orbit. So the multi-billion-dollar question is, how do you get a 9-ton spacecraft off the ground when your absolute biggest rocket can only lift half of that? Section 1. The 5-module relay race. Well, how did ISRO solve this heavyweight dilemma? They decided to break the mission apart, treating it kind of like a giant cosmic relay race. Instead of one massive, super heavy spacecraft, they've cleverly divided Chandrayaan 4 into 5 distinct components: the ascender, descender, propulsion, transfer, and re-entry modules. By modularizing the whole shebang, they can efficiently distribute that crippling weight. So instead of one impossible launch, ISRO is going to use 2 separate LVM-3 rockets to carry these different module stacks into space. The first launch will carry the re-entry and transfer modules, weighing a relatively light 1,527 kilograms. Then, about a month later, a second LVM-3 will launch the heavy lifting stack, the ascent, descent, and propulsion modules, weighing around 5,200 kilograms. Section 2. The first space handshake. Now, getting them into space in 2 separate pieces is really only step 1. Now they actually have to be put back together. These 2 separate module stacks must find each other and autonomously dock in an elliptical Earth orbit. Imagine trying to thread a needle while speeding around the planet at thousands of miles an hour. It's an incredibly vital maneuver and one ISRO actually just perfected during their SPADEX, or Space Docking Experiment mission. During that test, they successfully brought 2 spacecraft from a 15-meter hold point down to a 3-meter hold and achieved a seamless, rigid capture. That exact capability is what makes Chandrayaan 4 possible. Section 3. Digging at Mons Mouton. All right, once they're unified, the propulsion module fires up and pushes the fully assembled stack all the way to the moon. Upon reaching lunar orbit, the descenter and descender detach and touch down at a very specific location called Mons Mouton Site MM4. ISRO used high-resolution camera data from the Chandrayaan 3 orbiter to painstakingly select this 1 by 1 kilometer zone. It sits right between 84 and 86 degrees south latitude. They chose it because it's a highly strategic zone near the lunar South Pole, an area with a tantalizing potential for water ice. But crucially, it has a mean slope of just 5 degrees and plenty of 24 by 24 meter hazard-free grids, which makes it relatively safe for a touchdown. Now, this right here is where the magic happens. The descender module is equipped with a highly specialized tool set. A 1-meter-deep hollow drilling auger will penetrate the lunar surface to collect layered subsurface soil, preserving that vital depth information for scientists back on Earth. Meanwhile, a robotic sampling arm will scoop up surface rocks. The ultimate goal? To collect 2 to 3 kilograms of lunar material and tightly seal it in specific containers on the ascender module. This guarantees it remains totally pristine and uncontaminated for the long journey home. Section 4. The second space handshake. With the rocks secured, we enter the absolute highest stakes tension of the entire mission. Getting to the moon is hard, for sure, but getting off the moon? That's a whole different ballgame. The ascender module uses its own engines to blast off the lunar surface. It then has to locate and dock with the waiting transfer module, which has been patiently orbiting the moon this whole time. This is the second space handshake. Once docked, robotic systems will autonomously transfer the sealed samples from the ascender right into the re-entry module. After the handoff, the modules undock and the transfer module fires its engines to send the re-entry module hurtling on a ballistic trajectory straight back to Earth's atmosphere. Honestly, this perfectly illustrates the sheer audacity of this mission profile. Experts analyzing this mission have noted that this multi-step process is an incredibly delicate ballet where one single error means the entire mission fails. Every docking, every transfer, every engine burn, it all has to happen perfectly, entirely autonomously, hundreds of thousands of miles away from Earth. No pressure, right?
Section 5. Stepping Stones to Humans.
So you might be asking yourself, why go through all this trouble, risk, and massive engineering effort just for a few kilograms of lunar dirt? Well, because the payoff goes way, way beyond geology. These complex docking maneuvers, these space handshakes we've been talking about, are the exact foundational technologies required to build something much bigger. The upcoming Pardia Antariksha station, India's planned space station, will require multiple heavy modules to be launched separately and joined together in orbit. Chandrayaan 4 proves that ISRO can actually execute the autonomous docking required to build large-scale infrastructure out in space.
Chandrayaan 4, which is slated for around 2027, is clearly not just a sample return mission. It is the ultimate practice run for India's Vision 2047. It is directly paving the way for the Bhartiya Antariksha station in 2035, and eventually the monumental goal of putting the first Indian astronauts on the lunar surface by 2040. Because think about it. To bring humans back safely, you first have to prove you can bring rocks back safely. So as we watch this incredible cosmic relay race unfold, with its modular designs, its deep space docking, and autonomous robotic handoffs, it leaves us with a really fascinating thought. By mastering these incredibly complex, highly scalable technologies entirely in-house, is this the exact mission that cements India's place at the absolute top of the global space economy? It is definitely something to think about as we look toward the stars. Thanks so much for joining me for this explainer, and keep your eyes on the skies.